So in this video we're going to work an example of how to name a branched alkane, and what I'm going to do is I'm going to put up on the screen for you, copy the carbon chains, it's a lot easier to see. Take a minute, copy it down a sheet of paper, see what you can work through, and basically pause this video, and once you're ready to go, we'll get going. So the first thing we need to do is identify the longest carbon chain. So let's just take a few different options here. One was we can start down here and work our way around. So we've got this chain here, 1, 2, 3, 4, 5, 6. So this would be a hexane. Now you're probably looking at this and going, that's definitely not longest carbon chain. You're correct, but I mean, let's just kind of work through the process, right? Another option is we can look at this chain up here. So we have this part here, and if we look at it, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. This is no name, which is definitely longer than hexane, so we can get rid of this as an option. Now, there is one other carbon chain we can look at, and it's this one here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, decane. Now, decane is definitely longer than no name, so the parent of our compound here is going to be decane. This is going to appear at the very end. So our rationale here was just take a whole different roots, try a whole bunch of different carbon combinations, and see which one gives us the longest carbon chain. In this case, it's decane, so I'm going to leave the lines up here for us to see. This is going to be our parent chain. So the next thing is to identify the groups that are on it. Now we're not going to worry about naming, we're not going to worry about giving positions yet. We just want to identify what branches are on it. So if we look at it, we've got a methyl, a methyl, a methyl, a methyl, and an ethyl group. So our decane is going to be tetramethyl, and ethyl. So we have an ethyl group here and 4 methyl groups. Now the question is, do we number from here or do we number from here? And remember, our rule for this is we want to minimize the number at the first difference. So let's name it both ways. And again, don't try to do this in one fell swoop. I've seen organic chemists that still kind of have to work through this. So take the carbon chain, you can start on one end or the other, work it out. It doesn't really, if anything, it'll give you the practice of numbering the chains. So let's say we start with, this is the first carbon. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have our ethyl, 4 ethyl, 3, 5, 8, 8 tetramethyl, or yeah, tetramethyl. If we go from the other end, we start with this is 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in this case we have 7 ethyl, 3, 3, 6, 8 tetramethyl. So now let's compare the numbers. We have a 4 here versus a 7. So automatically off the bat, we see that by establishing this is the primary carbon, the first carbon, this will end up giving us the lowest number in the first difference. So the name of our compound here is 4-ethyl 3,5,8,8 tetramethyl decane. Way we work through this, don't worry about trying to assign the numbers at first. Start writing down what branches are coming off of it. Count them up so you get the correct prefixes. And then pick one end of the carbon and the other, write down the numbering, and see which one gives you the lowest number at the first difference between the two formulas. And that's how you name a complex branched alkane.